Yo, what's going on guys? I'm Code Red, and welcome to the third part on how to make a Rocket League bot using RedUtilities. In the last part, I taught you and introduced you to the concepts and basics of Rocket League bot creation, and I taught you the basics of using RedUtilities. And in this part, I'm going to teach you how to make your own strategy using RedUtilities and some core concepts in RedUtilities and functions that we'll use along the way. So let's get started. First, let's open up our folder, which contains our own Rocket League bot. You can see mine is right here. And we're actually going to want to edit some things before we open up our code. In this folder, I haven't really explained a whole lot, but we've actually got some pretty interesting things, which includes, all of the code for RedUtilities, all the code for our bot specifically, like our bot.cs file, which contains our strategy. And we also have this loadouts folder, which contains our bot's appearance, which we can edit using the Rocket League bot GUI, and this loadout generator, which is basically a bit of Python code that can randomly choose between any appearance files that we have in this directory. But the most important thing in here that we're going to be editing right now is this bot.csv file. Apart from the code actually running your bot, this is probably the most important file in this directory. If we open it up, you can see it says this file contains a ton of useful info on your bot and should be edited. So this is something that you definitely want to go in and edit right away. You can see, for instance, right here, it says developer is Code Red. And of course, you probably want to change that since you're the developer of your own bot. So put it whatever you want it to be. You've got a description, a fun fact. These don't really show up too often, but if you ever submit your bots to tournaments, these might show up on stream. The programming language, which is going to be C# since you're using RedUtilities, a link to a GitHub repository, the link to the executable. All of this stuff is definitely stuff you want to look at, but not the most important. The most important is this logo.png, so you can make your own logo, and the name, of course. So now that we're actually making our own strategy for your bot, let's call it something else. So I encourage you to come up with a name right now for your bot and change the name right here. So I'm going to, for this tutorial, I'm going to stop calling it RedBot since I'm going to start editing its strategy, and it's soon going to not be RedBot. It's going to be our tutorial bot. You can come up with any name you like. That's just, boring name. Anyways, now that we're done editing our bot's config file, we have one other file to edit before we can open up and edit our code, and that is the Python run file. When you open this up in either Notepad or, well, I'm doing it in Visual Studio Code, there is one thing you're going to need to change, which is this number right here, which is the port number that our bot runs on. Now, you don't necessarily need to know what a port number is, although hopefully you do know what it is. But all you do need to know about this number is that it has to be unique for your bot, so you're going to want to change it. Now, the easiest thing to do is to just change this number slightly. By default, it's 36969, nice. So you could make it 36968 or 36964 or something like that. However, be careful changing this port number to something completely different, because there are port numbers that won't work because they're taken by other programs. And in order to find out whether or not a port number is taken, there's a pretty useful Wikipedia article here that I'll have linked in the description that can give you some more information on what port numbers are, and also has a huge list of port numbers that are used by other things. So yeah, something to keep in mind, and definitely something you're going to want to change is this number right here. I'm going to change it to just 36968. And that will mean I can test my bot against RedBot and it should work properly. Now anyways, let's now open up our code. And once it's opening up, we are reintroduced to our code that, we went and overviewed in the last tutorial, including the strategy I went into quite a bit of depth in the last video. Of course, we're going to be editing this a ton, so this is probably the main file we're going to be spending most of our time. But first, let's do some quick changes and go over some things that I think are going to be quite important when editing this strategy. So first, let's change the name of our bot in our code as well. So you can see the name of this class of our RedUtilities bot class is still RedBot. So this doesn't really do anything, but just to be consistent, we can name it tutorial bot. Anyways, We're also going to want to change it not only in bot.cs, but the other place it's referenced is in program.cs, which I haven't gone over yet, but basically this is what makes your bot actually connect to the Rocket League bot GUI. It basically runs a server, and then the Rocket League bot GUI connects to that server. It doesn't really seem to make sense, maybe to you right now, because, you know, oh, servers are for connecting across the internet. This is all on my own computer, but it still runs basically effectively a server. You know, our bot GUI sends inputs to our bot, and we send outputs, or, well, inputs. You know, we send whether or not we're pressing space and all that stuff. You know, jump and whatnot. Anyways, the most important thing is we're changing RedBot to TutorialBot. And so that means that the server will start using our, you know, actual bot class, our new bot class named TutorialBot. And you can name it whatever you like, of course. Anyways, now we can actually start messing around with the strategy, right? But before we do, I want to quickly go over and fulfill a promise I had in the last video, which was explaining what this function does. This function is a lot of the magic behind why RedBot, despite having such a basic strategy, does so well. Because if you've played against RedBot or tested it against some other bots, it's surprisingly good. Well, it's still pretty bad. I mean, it's like probably silver level. But it's surprisingly good against other bots for having such a simple strategy where it basically always ball chases. And that's because of this FindShot function. As I mentioned before, the purpose of using RedUtilities is being able to write code like this that's a lot easier to understand when writing your strategy, and getting access to all of these cool mechanics that I've written myself for aerialing and double jumping and ground shots and jump shots and speed flips and things like that. And this FindShot function basically does some of that secret stuff behind the scenes and will pick an action for you. Now, how does it do that, you may ask? I want to know how my bot chooses its actions. That's kind of the point, right? Well, we can actually go and find where this function is defined by, you know, right-clicking and clicking go to definition. And you can see the FindShot function is actually really short. It's in the tools.cs, which is in the RedUtilities project. And there's a lot of interesting stuff in here that we don't have to go all through in this video. Definitely don't have enough time for that. But I encourage you to look through some of my code if you're ever curious about, like, oh, how does this function work? How does that function work? Just look through it. It might be a little bit confusing, but I tried to make it less confusing with as many comments as possible. And I'm going to start demystifying some of my code, specifically the ones that you're actually going to be using for your strategy, including the FindShot function. So what does this actually do? Well, if we just read the description, it searches through the ball prediction for the first valid shot given by the shot check. Now, at first, that might seem quite confusing. What's a shot check? What's ball prediction? Well, I explained what ball prediction is in the last video, I believe. Ball prediction is just basically where the ball will be in the future, right? When we're, you know, going for a shot, we're not going to be going for a shot right at where the ball is right now. We're going to be choosing a shot where we intercept the ball at some point in the future. And so we need to look to the future and choose a point in the future using ball prediction to go for our shot. And the point in the future that we choose depends on the shot check. And the shot check is basically a predicate. If you don't know what a predicate is, it's basically a function that returns true or false depending on the inputs that we put in it. So in this case, it will basically receive a shot check input, which encapsulates a function that finds the best shot for any ball, slice, and target. And a ball slice is just a moment in time. It basically will, you can see, it will return what is returned by ShotCheck. ShotCheck returns a shot, as you can see right here. This is the default ShotCheck. We can check that out in a bit. It will return the shot returned by the ShotCheck for a certain moment in time, and that moment in time is decided by this little bit of code, which, as you can see, it will search through, it will find a moment in ball prediction. It will look through the future, right? It will look for a moment in time when, for that moment in time, our shot check actually returns a shot. So our shot check's job is basically, we give it a moment in time. We say, we're going to try to go for a shot 3 seconds from now. And then the shot check will check if there's any way we can actually go for a shot 3 seconds from now. If we can, it will return the shot that it thinks we should go for. if not, it will return null. And this will basically search through ball prediction and go find the soonest moment in time where our shot check actually finds a shot to go for. And then it will return that moment in time and convert it into a shot by, once again, taking it through our ShotCheck function and returning the shot. And then that's finally what the FindShot function returns. So that's all of that in depth. A summary of all of that is basically the FindShot function will just look in the future, and depending on the ShotCheck function you put in, will return a different shot, right? And now, of course, the crucial part of the FindShot function is not really what it does. It's more of this ShotCheck function right here, which, of course, is what we're going to be checking out next. And you can see that in our default strategy code, we run FindShot and we give it the default ShotCheck. So let's see what the default ShotCheck does. As you can see, the default ShotCheck is, well, it might look a little daunting at first, but trust me, it's actually really simple. So as you can see, the default ShotCheck, well, actually all ShotChecks, are given a ball slice, which is a predicted state of the ball in the future. It's basically the moment in time I was referring to before, and a target, which is just the target that we're shooting at, right? And it will return a shot that it thinks we can go for. And basically, we first check if that moment in time is not equal to null, so it's a valid moment in time. Then we calculate how much time we have left, and then we make sure that we actually have time to go for that shot. It's, time remaining is greater than 0. And we can conceivably shoot at the target from where the ball will be in the future. So for instance, if the ball is in the corner in the future and we're trying to aim such that we will hit between the goalposts, it may not be possible at that moment in time because we don't have an angle. The angle is not possible, right? And that will account for that. But assuming that the angle is possible, then all this code is written, which is really where the magic happens. This bunch of code here, you don't really have to touch, but I actually will probably be changing this in the future. This is basically a bunch of code that basically chooses an exact target location for our shot. So we give the ShotCheck and, well, more specifically, we give the FindShot function a target, and then we give it to the ShotCheck, and then the ShotCheck generates an exact target. These targets aren't exact. These target classes aren't exact targets. They represent the entire goal, right? So, from the top right corner to the bottom left corner. This basically generates the exact spot in the goal that we want to shoot at. So the placement, right? Oh, I placed it top right. That's basically what this does. And by default, it basically shoots at whatever corner of the goal we think is just easiest to shoot at. And that's what this is. This is the exact spot we want to shoot at. And then, after generating that vector, it will then look through and generate all the different types of shots we can go for and check if that shot's valid or if it's possible. And if it is, we return that shot. Now, as you can see, we have kind of an order to these things. And this is where, creating our own shot checks comes in, right? Where this actually matters to the strategy is you can see that we first check if we can aerial for a shot. So the first thing we do is we check, is it possible to aerial for this shot? Now, there is like a bare minimum height for something to be considered an aerial. It's like double jump height is what would be considered an aerial. So assuming that shot, we can actually aerial for it in time and it's above that height, then we will go for an aerial. So that's the first thing we check. Then we check for a ground shot. Now, of course, ground shots are only possible when the ball is on the ground, so it's actually possible to hit the ball without jumping. So that, may return something or it may not. And if it doesn't, then we'll check for a jump shot, which is basically just jumping and then dodging into the ball. So, just a normal shot. And lastly, you'll check for a double jump shot, which is basically, it's a shot that mostly only bots do. It's basically an aerial, but without the boost. It just double jumps and then just points towards the ball. It doesn't actually boost towards the ball. It's really useful when you don't have any boost, but you still want to get up high, because you can surprisingly get pretty high with just a double jump. You can almost get to crossbar height. So this is a pretty good thing for like saving the ball when you have low boost and you're in net, right? Or just popping it over your opponents. And that's basically what this shot check does, is it will return a shot if there is one, and the shot will depend on what shots we actually want to check. So a really easy way to alter the way a bot plays a lot is literally just to edit the shot check. So if we want, we could just say, our bot doesn't go for jump shots or double jump shots. So we can comment that all out. So it only goes for ground shots and aerial shots. So if we were just to leave it like this and just save our bot, and if we click build and build solution, now let's test our bot, and let's test it by just doing, I don't know, a 1v1 versus, let's do self-driving car. Pretty good bot. If we start the match, we can now observe our new bot strategy. And as you can see, our bot does in fact have the name tutorial bot now. And let's go see what it does. You can see in the top left, we can see what shot it's trying to go for. So it says it's going for a ground shot, which of course it should be going for. It's kind of going backwards right now, but that is in fact still a ground shot. And you can see, well, it's not playing very well because, believe it or not, it's pretty good to go for, you know, jumping and dodging shots. But as you can see, it is doing in fact what we wanted. It will only go for shots where it doesn't have to jump. As you can see, it jumped there. I think maybe it thought it could go for an aerial. Because it can go for aerials. You can see it tried to go for one there. But you can see our strategy is in fact working. It's not working well against self-driving car, but it is working. So that's a simple way to change the behavior of our bot. Now, let's actually get to some more complicated strategy and try out making our bot go and get boost instead of always chasing the ball. So, let me close Rocket League bot real fast. And now, let's undo that for now. We can leave the shot check as it is. And let's make it so our bot does left goes and goes for boost. That's our goal for this video. Let's make it go for boost when it's appropriate, and let's make it follow left goes. Because if we look at the kickoff code right here, as you can see, going for kickoff is a Boolean value, and it's by default equal to true. Then we go through all of our teammates, and going to kickoff will remain true, assuming this is also true for all of our teammates. And now what is this, you're wondering? Well, it's basically checking if our distance to the ball is less than or equal to this particular teammate's distance to the ball. So if that's true for all of the teammates, then we will go for kickoff. If any of the teammates are closer to the ball than us, then we will not go for kickoff. But that's the only condition where we won't go for kickoff. Meaning, if a teammate and us, our bot, is the same distance from the ball, then we will both go for kickoff, assuming the teammate also thinks it's a good idea to go for kickoff. Which of course is not what we want. So let's add left goes. Now, how are we going to do that? How are we going to check if we're on the left side of the field? Now, there isn't something default to RedUtilities to check this. However, we can start using our own brains and figure out how we can check if we're on the left side of the field or not. And to do that, let's go to the Rocket League bot wiki, which I'll have linked in the description. This page in particular contains a ton of useful information, including this handy dandy map of, well, the Rocket League map. Just any standard Rocket League map. You can see we have the blue side and the orange side, and the positive X direction is to the left side relative to, you know, the blue side of the field. And if we're on the orange side, negative X is to the left. So let's make that through code. So let's go in here and let's add another condition here. So let's modify this condition. So we'll go for the ball if we are already going for kickoff, and we are less than the distance to the ball from this teammate, or we are equal in distance to this teammate, and this line is getting pretty long, I should probably simplify it, and we are left. It is left. So let's make a function, or a variable for is left, and also let's simplify this a bit. So I'm going to make some other variables here. One is going to be for my distance to the ball, and the other is going to be for our teammates' distance to the ball. There we go, a lot easier to read now. And now let's actually make the new variable here is left. And we are going to do this by checking the sign of our x value for our position. So we do mathf.sign, not that kind of sign, sign for me, which is our car, dot location, so our location, dot x, which, you know, the x coordinate is in fact left and right, as we can see on this handy dandy little mini map. So we're checking the sign of our x location, and we're going to check if it's equal to. Now, how are we going to make it -1 and 1 for if we're on the blue and orange side? Well, luckily there is something kind of like this in RedUtilities. There's the field.side function, which if we check the definition of it here, right here, it says it returns the side of the field which belongs to the team given. -1 for blue and 1 for orange. So we just have to input our bot's team, and this will return -1 if we're on blue and 1 if we're on orange. Now, is that exactly what we want? Well, not quite. You see, this is for the y coordinate, so this is returning if we're on blue, then it's -1 because we're on the -y side, and 1 if we're on the, you know, orange side. But in this case, we're doing it for the x coordinate, and specifically if we're to the left and stuff. So in this case, this returns if we're on the blue side, this returns -1. Now, -1 would mean the right side relative to the blue side, which is not what we want. We want it to be positive x if we're on blue and negative x if we're on orange. And this does negative x if we're on blue and positive x if we're on orange, which is the exact opposite. So we can just do negative field.side, or we can do does not equal. Let's just do does not equal. So now it will check basically if we're on the left. And if we're on the left, then we will still go for kickoff even if we're equidistant, but otherwise we will not. So there we go. We've implemented left goes pretty easily, right? Now let's actually try it in game. So if we do build solution, let's just make a bunch of tutorial bots on each side so we can hopefully get a kickoff. Actually, let's do 5. I think we could do 5. That should be for all of the kickoff spawns. Now, if we wait for Rocket League to open, we should get an absolutely crazy match. And once it loads, we should only see this left bot go for kickoff and everyone else go for boost. And that's exactly what happened. Those two bots went for kickoff and everyone else went for boost. You could see it was kind of laggy for a while. Oh my god, they're all going for aerials. Oh wow, this is crazy actually. Look at that. This is crazy entertaining. Anyways, they kind of hesitated there on kickoff. I think it was because there were so many and they had to all load in, but you can see our left go strategy actually worked. Now, of course, let's do something about them all swarming the ball. They're not really working as a team, as you can see. They're kind of all just going. Like even in a 1v1, they're just ball chasers. They're ball chasers all the time. They don't have any team chemistry, which we're not going to be working on this time because that's a little hard and a little bit much for this video. We're just going to be making them be a little bit more reasonable. And then if you want, you can add team strategy. Ooh, wow, that was a close shot. Anyways. Hey, blue won. Now let's add the boost collecting functionality. Now to add our boost collecting functionality, we are going to want to edit this part of our strategy code, which currently is basically where all the action happens. This is basically just when kickoff happens, and this is what happens the rest of the time. As I explained in the last video, if you want to see an explanation on how this whole strategy works. But basically, if we are on kickoff and we haven't decided what to do yet, then we go for kickoff. And either the thing we do on kickoff is a kickoff action or a get boost action, depending on whether or not, you know, we are first to go to kickoff, which is what we just changed. We just changed this code that decides whether or not we're going for kickoff or going for boost. This code is the code that runs when kickoff is not true. We check if we have yet to decide on an action, or the action is basically one that we can interrupt, like driving back to our goal, which is basically a backup if we can't find a shot. And if either of those conditions are true, then we look for a shot, and if we find it, that's our new action. That's basically all this does. Now, to add a get boost functionality, how do we want to edit this? Well, when this condition, this whole thing is true, we're going to look for a shot. But we only want to look for a shot if it's actually reasonable to do so. So let's add some conditions to this stuff. So let's add an if statement. So I could say if me.boost is less than 20, then we will do something different. So we could just go for boost in this case, but that would result in us going for boost far more often than we should. For instance, we're about to score a goal and we're less than 20 boosts and we'll just run away from the goal. So what exactly do we want this condition to be? Well, it could really be anything. And there are plenty of ways you can go about this, some smarter than others. But we're not going to go into the most in-depth ways of testing this. Let's just do a basic one for now. So if our boost is less than 20, and we can use a default built-in function in RedUtilities called, it's under the drive class, drive.getETA. And this will basically get a rough estimate on how long it will take to drive to a location. We pass in our car, which is me, and then we pass in the location, which in this case, let's just do where the ball is right now, which, if you remember correctly, that's not exactly the best way of going about things, because, actually, you know what? Let's just do it like this. So, we can do it the way we were planning to do it, which will basically test how long it will take to drive to the ball's exact location at this moment, right? But as we discussed with the finding shot functionality, that isn't actually how long it will take to intercept the ball. For instance, if right now the ball is on the other side of the field, then this function will return like 10 seconds or something in order to drive to the other side of the field, and you have less than 20 boost. But if that ball is heading towards you, it will probably take a lot less time. But this doesn't consider that because it's just looking at the time it will take to get to the ball's location at this very moment. Versus what we're really asking is how long until we intercept with the ball. Now what's cool is we kind of already do that. This FindShot function finds an intercept with the ball. So what we can do is we can just use this shot intercept. Now remember, FindShot sometimes doesn't return a shot if we don't find it. So first we're going to want to check if shot is equal to null, or the drive.eta is less than, or is greater than some amount of time, then we'll go for boost. Now, why am I checking if shot's equal to null? That's because if we can't find a shot, that means we're so far away from the ball that there isn't a shot that we can get to in the next 6 seconds. Which, in this case, I think if we are nowhere near the ball such that we cannot get to in the next 6 seconds, I think we're safe to go for boost then. So, shot is equal to null, that's one condition, or shot dot time? No, what's it called? Shot.slice, which is the ball slice, the future ball state at which time we are planning to hit the shot. And we can check the time at which that prediction happens, and minus the current time. And this basically gives us how long until we are supposed to hit this shot. So if this shot is going to be hit 3 seconds from now, more than 3 seconds from now, then we're safe to go get boost. And actually, we could even increase this, but let's just try that for now. So if either of those conditions are true, then we'll set action equal to new get boost. And we're going to pass in our car. And this, we've got some other extra options in here. For instance, we can pass in a specific boost index, which is, you know, we want to go for a specific boost. Interruptible means whether or not we want this action to be like one that we can actually interrupt, which while we're getting boost, if suddenly we find that we have more than 20 boost or we can get a shot in the next 3 seconds, we want to check and make sure that's the case. So we're going to set interruptible to true. And so we're going to actually modify this if statement up here so that it says or action is drive or action is get boost. So get boost and drive are basically actions that are interruptible. And will be, if assuming that we're not like flipping while getting boost or driving back to our own goal, then we want to be doing all the logic in here so that we can check if there's a shot, because shots are more important than going for boost and stuff. Although you can, if you want, not add this in, and so your bot will probably act like boost is more important than ball, which, you know, it's up to you if you want to add that functionality. But in this case, we're going to try to make our bot as reasonable as possible. So if this is all the case, then we'll set our action equal to new get boost. But we only want to do that if the action isn't already a get boost action, because we don't want to reset it to a new action every frame, or else certain parts of the action will execute properly. For instance, you will never dodge while trying to get to a boost location if you just reset the boost, the get boost function every frame. So instead, we're going to check action is not get boost. It's very weird you can just actually do the keyword not in this scenario, but, you know, easier to read, I guess. Is not boost, then we'll set it to get boost, the new get boost. Otherwise, we'll set it to our current action. I think this might be the functionality done. This is a very quick if statement and just an example of the kind of strategy you could have. And we're not going to have time to make a fully fledged, you know, amazing bot in this episode. I'm just giving you an example of how you can modify the strategy code. And even though this modification is very simple, I think you get the idea on how you could add more to this. So let's finally build our solution. And once it's done building, we can now test our solution. All right, let's try our tutorial bot against, let's try putting against myself. It's not gonna beat me because I'm like champ 3 currently. And my bot, red bot and this bot are probably like silver, maybe gold. But we can still try out the new strategy and see if it works properly against myself. All right, let's see how I fare. I beat him on kickoff. All right, I feel like he should have went for boost there. Okay, so this is just a dumb, stupid mistake on my part. I meant to do return on this. So after this function, after we go into this if statement, we don't want to then set the action to equal to a new shot. We need to just return out of the function at this point so that our action's just set once. And that was just a dumb mistake on my part. I should have seen that coming. So anytime you want to set it to like a different branching path, make sure to return out of that function at the end so that everything below, or you could just, alternatively, you could just do else. That would probably make it a lot easier so that you don't run into the mistake I just ran into. But I like doing this return personally. I think it looks better. But anyways, regardless, this will now make it so that this part of the function doesn't run if we decide it's more important to get boost. So now it probably will go for boost all the time because 2 seconds is a little bit low. But it will now show you an example of the kinds of strategies we can make. All right, time for the 1v1 against me, against our new bot. And it's getting boost, yay! You can see it got that boost and now it's decided to go for the ball and it missed. You know what? Honestly, should have expected that. And you can see it got that boost and now it's going for the ball. And it owned gold. No, it didn't. Actually, all part of the plan. Now it's dribbling. But I easily counterattacked. And I score. Well, our bot's not perfect yet, but you can come up with your own strategy to improve our bot. But as you can see, our new strategy is working, and you can take the lessons in this episode to actually start designing and creating your own strategy. And, of course, you can, you know, figure out how to use the shot checks a little bit more now that I've explained them. You can use different combinations of these different actions. You can even create your own actions, which I don't think I'm ever going to explain, since this is going to be the final episode of the RedUtilities series unless I decide to make more. This is probably the final one. But if you want to go more advanced, you can create your own actions. You can see how I implemented them here. But you can, for sure, at least I recommend making your own shot check. So like, if you're doing a shot, maybe like, you're doing a save, maybe you don't want to go for ground shots. You want to always flip into the ball or double jump or something when you're going for certain types of shots. Or maybe you want to only go for ground shots when you want to dribble or something. But yeah, as you can see, hopefully I've shown you how to create your own strategies with RedUtilities in this episode. And if you liked the video, please hit the like button down below and subscribe if you want to see other coding videos that I will be making in the future, mostly relating to Unity, but definitely some more Rocket League and Rocket League bot stuff happening in the future as well. And I'll see you in the next video. Bye!